Introducing OpenEye's 2023.1 Suites and Modules release highlights, including new features, flows, and enhancements. Kicking off with Gigadock Warp, we've improved the flows algorithm by training a linear regression model of the docking score based on OpenEye's fast rocks calculations and other molecular features. With this new docking score model, Gigadock Warp can now generate a hit list with over 90% similarity to Gigadocks, at a cost that is an order of magnitude less. In this release, we've introduced several protein sampling flows that begin with the solvation and equilibration of a protein system. First, the A1 solvate and equilibrate target protein flow allows for use of water-xenon mixed solvent or a single solvent for solvation. Next, you can perform protein normal mode analysis on the solvated protein and use up to 2 selected normal modes to perform a weighted ensemble simulation. Subsequently, the output generated by a weighted ensemble simulation can be analyzed to search for cryptic pockets using the cryptic pocket detection flows introduced in this release. Speaking of cryptic pocket detection, we now provide 3 methods for cryptic pocket search from weighted ensemble simulation data. For the simulation set up in a water-xenon mixed solvent, all 3 methods, including exposon, cosolvent binding free energy, cooperative cosolvent binding analysis, can be used for cryptic pocket detection. And if simulations are performed in a single solvent, exposon analysis will be the only method available for cryptic pocket detection. Note that all 3 methods of cryptic pocket detection report an interactive network of cryptic pockets, wherein the pockets are ranked by their distance from a user-selected functionally important site. Each node in this plot represents a cryptic pocket. Clicking on a node displays the pocket-forming residues, and hovering over a node will display metadata related to the pocket. Edge connections between any 2 pockets signify the degree of cooperativity between those pockets. The network allows users to select an appropriate cryptic pocket for further analysis and create a receptor for gigadocking. Lastly, our receptor creation flow generates a dataset containing receptors and the pocket volumes that you can visualize on the Analyze page and select an appropriate receptor for gigadocking. The structures can also be assessed for similarity to known liganded pockets. You can do this by using them as queries for a site hopper search on a database on known protein ligand binding sites. In this release, we're introducing induced fit posing to Orion. This flow is a new pose prediction tool for the hit-to-lead stage of drug discovery that features a 3-step protocol for the correct prediction of the binding pose of a ligand that requires induced fit of receptor binding site residue side chains. The 3-step protocol comprises the initial docking of the ligand of interest to the reference receptor, MD-aided induced fit of the post-receptor conformations, followed by the scoring of the conformations. Once the flow is successfully completed, it outputs a flow report that displays information about ligand-receptor interactions for the top 5 ranked induced fit post-receptor conformations, and the output dataset, which you can view on Orion's 3D and Analyze pages. This release features a new version of the classic CHOMP flow that can handle larger molecular databases more efficiently. Improvements include the option to input data as a dataset, file, or collection. The 3D fragment database output from the flow is still a tar.gz file. However, the 2D fragments are written as a collection. Note that the 2023.1 flow is significantly faster and cheaper than the previous version. This will act as a drop-in replacement for the existing classic CHOMP flow. In this release, we've increased the scalability of QM calculations in the cloud by leveraging Gaussian's benchmarking capabilities and the Orion scheduler and parallel cubes. These flows have now been benchmarked for hundreds of calculations running simultaneously. The QM fragmentation and torsion scanning flows can now support larger input datasets by deduplicating fragments. In this release, we've seen up to a 60% decrease in cost for the same input molecules. Additionally, the flow reports also include more details, highlighting the torsion angles for input conformers, and comparing the force field and QM torsion scans. Also in this release, torsion scans and all geometry optimizations in the Sci4 flows have been improved by the option of the Geometric Optimizer, which has been shown to be more robust, especially for constrained geometry optimizations. Overall, these improvements will make QM calculations on Orion more reliable. In this release, we've improved our machine learning model building flows with the addition of a Curious hyperparameter tuner that will optimize the hyperparameters in your flow to build better, higher performing models automatically. Debuting in this release, the hERG toxicity model flow is a classification model that identifies compounds as high or low toxicity and explains the prediction by highlighting chemical moieties that contribute to hERG toxicity. Finally, you can now update your existing machine learning models to include new data, saving you time and resources, and allowing for the opportunity to compare models over different points in time to test for domain of application. For more details on the Orion Suites and Modules 2023.1 release, visit docs.eyesopen.com.